Rightio, ready for the magic shortcut? So, in some cultures, people jump from tall buildings with vines attached to their feet to prove that they are becoming a man. In some cultures, they put their hands in bull ants' nests to prove they can deal with the pain tolerance to earn the right into adulthood. In our culture, we do calculus. And this is your rite of passage. This is when you go from being a boy to a man,
I prefer the building.
a girl to a lady. So please be ready for the experience. Some would argue that this is more torturous than putting your hand into a bull ant's nest. Some would rather jump off a 90-metre building with a vine attached to their foot. We've toiled through the hardships of first principles, understanding how we reach the shortcut. Those of us who are more able may have already seen the shortcut presented to us. We may already feel that we are ready to take the step of adulthood. But just in case, and just know that some of your peers will never reach this point in their life. Those general maths kids. They'll never hit the peaks of adulthood. So when you walk through the class, or when you walk through the playground today,
I do general
walk around with a sense of pride, knowing that you've reached this rite of passage, and feel sympathy for your peers. They will never know the beauty of calculus or the responsibilities that comes with your rite of passage. We are looking at the shortcut, and the shortcut makes your life significantly easier. Now that you've dealt with the trials and tribulations of first principles, we can now move on. This is how it works. In reality, you will very rarely use this. The only time you'll ever use first principles from this point on is when it says using first principles. Happy with that? The shortcut. If I have a function with a polynomial y equals x to the power of n, what does n represent?
exponent.
Yeah, it's an exponent, but it's any number, correct? It's a power, but it can be any number. The rule simply states that I multiply the power down and take 1 off the power. So you thought I was weaving my magic before when you said 8 times x to the power of 9. Derive that, sir. 72x to the power of 8. That's the power of this rite of passage. You can now derive any polynomial function at the drop of a hat. So let's go through some examples here. If I've got y equals x to the power of 7, I bring the 7 down, take 1 off the power, 7x to the power of 6. What's the difference in this example? Riley?
It's got a multiple outcome.
Got a coefficient at the front. Okay, that doesn't affect the derivative. The only thing that we do is we multiply 4 by 6 and then we take 1 off the power. Happy with that? Be aware of these functions here. They come up a fair bit. So if I've got 4x to the power of what? What's that? X to the power of 1. So I multiply the power down. What's 4 times 1? X to the power of 0. What is anything to the power of 0? 1. So I should have 4 times 1, which is 4. If I think about the graph of that function, what does 4x look like? What is it? If I was to,
Straight line.
it's going to be a straight line, correct?
Yeah.
Does it make sense that the gradient of that function always stays the same? The tangent of that function is always 4, correct? No matter where I am? Does that make sense? Y equals 7. Why does it make sense that that has a derivative of 0?
Because the gradient is 0.
If I draw that function at any point in time, what's the gradient of that line?
0.
Horizontal, so it's 0, correct? The other way that makes sense is because 7 is equal to 7x to the power of 0, correct? Because anything to the power of 0 is 1. So I take the power down. What's 0 times anything?
0.
So 0 times 7x to the power of negative 1 if you want. Doesn't matter what it is, it's going to be 0. Cool? If you understand those, you're in a good spot. The last thing you need to understand is that this breaks every time we have a plus or a minus. So you can apply the strategy to the next term, providing there's a plus or a minus. Does that make sense? Why can't we do it for multiplication and division? Why can't we apply a new set of rules? Why can't, if I had y equals x to the power of 3 times x to the power of 2, why does that not equal 3x squared times 2x? Why does that not work?
You got two x's and not together.
Well, what's an exponent? What is that power? What should I do with these before I do anything?
Add together.
Add them together. Because x to the power of 3 times x to the power of 2, it's the same operation, correct? Whereas with a plus, we've got a clear break in operations. Happy with that? So plus and minus, we can move to the next term. Multiplication, division, we need to simplify our terms before we go forward. So this shouldn't take very long. One thing I will note is when we're deriving, just be aware of this. When we're dealing with y and x is our variable, to show that we're deriving, we use dy dx. If I've given the function fx, so if it's in that notation where it's fx, to show that I'm deriving, I have f dash x. Cool? If I had a function that was, say, m equals 4s plus 5, I shouldn't use s and 5, let's use 2. 4s plus 2. What do you think that would look like? dm ds. Very good. And the derivative of that would be 4. If we think about what that means, that makes sense. Why does that make sense? Because what is this function? What are we deriving? What is that all about? Think back to the first lesson. It was all about
Change.
what change?
Instantaneous change.
Instantaneous rate of change. So I'm saying, how does y, this d means change in y over change in x. Happy with that? So if I wasn't dealing with y's and x's, if I was dealing with m's and s's, it would be change in m over change in s. Who feels that we can get through these in under 2 minutes? Do you want to go through them together and give you some examples, or you want? I'll do.
Do 4.
I won't do 4. Let's go through it quickly. I'll give you 5 seconds to write down the first one.
6x.
To write down the first one, and I'll ask the class.
Jump in the zone.
All right, Tom Henderson. First one is 6x. Very good. And what have I missed? I should have written something. On the left-hand side, I should have written f dash x equals. Second one, thanks, Caleb.
6x.
Nothing else? Very good. Good question. C, thanks, Liam. I'll give you 5 seconds. I haven't given you any time. Sorry, 5 seconds to have a go at C. Too much pressure. Too much pressure.
Yeah, hold on.
And Sarah, you can do 4. You've got it? You can do 4 first then. Yep.
3 over 2x to the power of 5.
She's good. She's very good. Liam? Start, just go 1 step at a time.
I don't know.
Oh, power down. What's
Two.
x to the power of 2? What's the number in front? We bring the power down so it becomes?
3.
Yep. Plus? Power down?
4. X.
Yep. Minus? Go through it. Commit to it. So what you're saying, I can hear you saying. Minus? Good man. Happy with that? What I want you to do now is you are going to write on your page a polynomial. You're going to write on your page a polynomial. You're going to turn the next page over and you're going to write down the derivative somewhere on that page. And you give it to the person next to you and see if they get the same answer. Let's rock and roll.